So today is going to be kind of the start of our review activities. And what we're going to look at for today is page 29 and 31. So 29 has all these boxes with all these different function forms on them. And then 31 has all these graphs. Page 30 is blank, except for it has that little 30 at the bottom. So feel free to use page 30 for sketchwork if you need to. But what we're going to look at is how we can convert between these different function forms. So that's what we're going to practice today. We've done this already. This is going to be, again, review, refreshing before our test at the end of this week. So at page 29, let's take a look at this first box. So we've got here our function in standard form. We've got a space to put our function in factored form and a space to put our function in the vertex form. I know that this bottom one is vertex form because it's got a square here. And remember, vertex form is x with something squared and then that y term at the end. Okay. Factored form would be x and something, x and something. And so that's what I see for almost all of these boxes. We've got one here that says no x-intercepts, meaning we wouldn't have a factored form because factored form gives us x-intercepts. So if I don't have x-intercepts, no factored form. But for pretty much everything else, we'll have those three versions of our function. Okay. So for this first box, we're starting with standard form. And I want to change this to factored form. This is what we worked on last week. I need factors of negative 35 that would add to 2. 7 and negative 5. So my factored form would be x plus 7 and x minus 5 if I want positive 7 and negative 5. Now I also want vertex form here. So that's going to be that completing the square process that we looked at a few weeks ago. So from standard form, I'm going to split my middle term. So x squared plus 1x plus 1x plus something minus 35. And then whatever I add here, I also have to subtract at the end. I'm going to fill in my blanks with that cut in half number squared. So 1 squared is 1. And then this portion here up to that first blank, I can write as x with something squared. Now the something is always going to be that cut in half number. So x plus 1 squared, since it's positive 1. And then my y term comes from these last two numbers here. So negative 35 minus 1 would be negative 36. So there's my vertex form. X plus 1 squared minus 36. So there are my three versions for this quadratic function. And now really quickly, I'm going to jot this down on a Post-it just so that we don't have to keep flipping back and forth on my notes page up on the screen. I'm going to jot down some key information from this function. The y-intercept that I got from standard form is negative 35. My x-intercepts that I get from factored form would be negative 7 and positive 5. Negative 7 and positive 5. And then my vertex, which comes from vertex form, would be negative 1 comma negative 36. There's one more important piece of information that I can get from these functions, and that's based on the lead coefficient. So if I look at the front of each function, I don't see a number there. That means that it's just 1. And since it's positive, that tells me that this is going to open up. So my parabola is going to open up like that U shape. So with these key features in mind, I'm going to turn to page 31. And I'm going to look for a parabola that has all of these key features. So a y-intercept at negative 35, x-intercepts at negative 7 and positive 5, and a vertex at negative 1 comma negative 36. I also want to make sure my parabola opens up. So which of these graphs meets all of these criteria? Hannah? Graph 9, a y-intercept at negative 35, x-intercept at negative 7 and positive 5, vertex at -1, -36, and it opens up. Perfect. So this first one matches graph 9. So that's what we're doing here. We're trying to figure out all of the different versions that we could use to represent a particular quadratic function and then match it to its graph. We'll do one more together here. Let's take a look at the second box. Second box down. So we've got a portion of standard form here. We're missing all of factored form, but we do have vertex. We practiced a few weeks ago going from vertex form to standard form. We had to distribute to do that. So that's what I'm going to do here. So remember when we distribute this thing that's squared, I write it twice. So this would be x plus 4 times x plus 4 minus 1. And then when you distribute, make sure you're multiplying everything. Distribute completely. So x times x is x squared plus 4x plus 4x plus 16, then minus 1. When we combine our like terms, we have x squared plus 8x. So far that matches, that's good. If these did the math that I have here, I would want to go back and double check my distribution. And then when I combine my like terms at the end, 16 minus 1 would be 15. So plus 15 is how I'm going to finish up my standard form. And now I want factored form. So I'm going to look for factors of 15 that add to 8. So what two numbers would multiply to give me 15 and add to give me 8? Positive 5 and positive 3. So my factors would be x plus 5 times x plus 3. Good. So I've got my 3 function forms. And now let's jot down those key features. So my y-intercept is at positive 15. My x-intercepts would be at negative 5 and negative 3. My vertex is at negative 4, comma, negative 1. And again, based on that lead coefficient, since it's positive, I know that this is going to open up. I'm going to take this information and flip to my graph page. I'm going to just, since these both open down, I know it's not either of those, I'm just going to stick this here while we're looking at our graph options. Y-intercept at positive 15, x-intercepts at negative 5 and negative 3, and a vertex at negative 1, comma, or negative 4, comma, negative 1. Number 6, yeah. So an easy mistake to make here would be to say, well, I think it's number 1, right? It has the right y-intercept. They don't label the vertex on this one, but I've got x-intercepts at 3 and 5. The difference between these is I want negative 3 and negative 5, right? And that's number 6. And they also label that vertex. So this would be graph 6. Graph 6 there. So that's what you're going to look up for each of your functions on page 29. Okay? What are those 3 forms for this function? And then which graph do they match? I'm going to leave Zoom open. So if you guys have questions, please ask. But you do not have to stay on Zoom for today if you don't want to. As a reminder, no Zoom for the rest of the week. For tomorrow, if it's your remote day, you're going to be working on review in your pocket. So it's on page 25. In person, we'll be working on some more review and revisiting those factoring quick checks. Same for Wednesday, and then Thursday, Friday is your